This conference will now be recorded.
I welcome you all on day 5 of a 5-day FDP on high-speed wireless and optical technology covering global network. So today's we are having 3 talks followed by a valedictory session which will be having MCQ type of a test which is compulsory, and 60% of marks should be there in order to get ready for the certificate. So today session 12 and 13 and 14 will be there. Session 12 right now will be handled by Dr. Sandeep Vijay. He is Professor and Director at Tula Institute, Dehradun, Uttarakhand. We will be talking about high-speed communication beyond the thinking, paradigm shift from 5G to 6G. So now I request Ashi to formally welcome sir.
Morning, everyone. Dr. Sandeep Vijay is an acclaimed professional with 21 years of rich experience in teaching, administrative, NBA and NAAC and research activities. He has accomplished successful completion of major research projects independently by BSI and DAIICT Gandhinagar in the field of VLSI design. He has successfully guided 7 PhD candidates and 8 ongoing at Government University U2U Dehradun. He has effectively supervised over 42 projects and dissertation of MTech and BTech. He also undertook several foreign university professional and research visits such as King's College, Kensington College, Imperial College London, Oxford, Brookes University, Headington Campus, Headington Hill, Oxford. And Dr. Sandeep Vijay is an esteemed academician having the distinction of being associated with numerous seminars, study tours, presentations, workshops, talk invitations, conferences, as well as publishing of a plethora of articles and research papers. He has published more than 175 plus publications. Today, he'll be talking about high-speed communications beyond the thinking, paradigm shift from 5G to 6G. Welcome you, sir. Over to you.
Good morning. Thank you very much. And I'm starting my presentation. Are you able to see my presentation?
Yes sir, your slide is visible.
Fine. Thank you. So I'm going to discuss today about the high-speed communication beyond the thinking pattern shift from 5G to 6G. Now, before giving the information about the 6G, first of all, we should discuss about the 5G because that is very, very important, and how we are shifting it from the 5G to 6G. That is the connective path. Now 6G, what networking and connectivity promises we have already given, that is an important part of it. Although 5G networks are just now coming into the reality, especially in India, when we can see the technologies are already working on the next big thing, the 6G future. If we are learning anything about the 5G implementation, it's that the demand of connectivity is increasing and the exponential rate as the wireless communication is becoming more and more essential to our daily lives, from self-driving cars to internet connected coffee machines, from the smart sensors that monitors the medical condition to the factories full of robots, and the power of wireless in pushing the entire world forward. So basically, how we can shift from the 5G to 6G, that is an important thing. But before that, we have to look into the 5G technologies. Basically, when we talk about the 5G, what is the 5G technology? Generally, it is the fifth generation cellular technology, starting from first generation to fifth generation. There is a lot of change. When we have started from simple bits, now we are running to multi-gigabits data rate. And you can see the immediate change in the 5G technology is within 1 millisecond or less, we will send around 20 Gbps, and it is more activity for the enterprise application, and it is we are using augmented reality, even virtual reality, Internet of Things, and location awareness, branch connectivity. Everything is basically connected with the 5G. When we look into the 5G, how 5G works, basically the its wavelength spectrum varies from 30 gigahertz to 300 gigahertz, and it's
Excuse
basically
me,
it travels short distances. And
sir.
yes,
Sorry for
please.
interrupting. Sir, your voice is a little bit low, sir.
Okay, okay. Now you are getting voice. Are you getting a clear voice now?
Okay, sir.
Is it okay, or shall I increase my voice? Just wait it. Okay. Now 5G wavelength spectrum is varies from 30 gigahertz to 300 gigahertz, and basically it is the standard and a project driven by 3GTP, third generation partnership projects, which is working for 5G standards, and it is completely increasing day by day in its standards and giving the final projects. It is basically a part of LTE standards, and the 5G radio supports the growth of wireless communication, which enhances the EM spectrum. If we can see, we are not going to the 1G and 2G networks because that was very, you can say it is very slow. Now we are talking from 3G to 5G. If we talk about the 3G to 5G, if we think that how long would it take to download the 2 hour long Guardian of the Galaxy, this book, if we want to download it in 3G networks whose speed is around 384 kbps, it took around 26 hours to download. Means in that particular time you can fly from New York to Sydney, including check-in time also. So see the entire time, that is 26 hours it will take to download this particular book. When we have shifted from 3G to 4G with 100 Mbps, it took around 6 minutes. It is just simply a run a mile, catch up on the Facebook for 6 minutes. Within 6 minutes, we are able to download it. And in 5G technologies, it took around 3.6 seconds to download the entire thing with 10 Gbps. If we are talking about 6G, basically 6G is what they are giving is, in 6G we should download the entire this particular content within 0.2 seconds with 100 Gbps. Just think how we have shifted from 3G to 6G. Right now we are in the 5G spectrum, and we are basically working on the 5G itself, especially in India. However, the trial for 6G has already been done by the China, and US has already taken it. But still, it is in the testing mode. Right now, nowhere in the world they are using it commercially. Now, if we think about shifting from 5G to 6G, what are the target scenarios and what are the critical requirements? That is very important point. Right now in India, the concept of a smart cities has come. Now various cities are basically converting into the smart cities. We have self-driving cars now, internet cars is available, especially in India. Then we have the mission critical applications where their industry automation is there, AR, VR is there, the smart home buildings are there, even smart cars are there, which can be controlled by your mobile. Voice control devices are there. And number of applications are there, and we are required to take care of the entire scenario. by enhancing our mobile broadband. Now this is the first requirement we can say for shifting from 5G to 6G. Second one, the second scenario and critical requirement is the capacity. Right now the problem is that we have a massive infrastructure development is going on and huge density over a large geographical area that is basically equipped with high technologies, and it requires high financial flexibility. Otherwise, it is not possible to cater the entire capacity. Now, new NIS and business opportunities are already available in not only in India, in the entire world. And we have new value chains actors are there, which basically directly impacting on the capacity. Now, if we look into a 10 year back around within 1 meter, it is almost we can say zero point 0.5 persons are available or zero point 0.5 equipments are available to get connected with each other. But if we look into the 5G communication means right now we are at 2021. In 2021, for every meter there will be one mobile devices are available. If we look into the entire geographical area of India, and in 2035, when we are projecting that 2035, it is around the capacity required to increase, because at that time per meter you can have 3 to 4 devices that will be available within 1 minute. So until unless we can, if we cannot increase our capacity, how we can cater the entire thing? That is very, very important. Second thing is we have the crowded local access. We have massive data local access for the dynamic clouds, which can basically interplay the technological and architectural innovations. So that is very, very important. Although it is there in the US also, and all foreign countries are already have the massive data consumptions. So we have to take care of that. Third massive requirement is basically we have to look into the connectivity, because 5G will accommodate for busty IoT communications. That is okay. Means n number of IoT communication, whether it is the automation, whether it is the industry automation or home automation, or it is the you can say club automation, whatever it is, they are taking care of it. As well as they are taking care of the mobile devices, they are taking care of all the different type of communication devices. But still there is a big challenge with the QoS requirement, because the QoS, if we talk about QoS quality of service, it varies from person to person, it varies from customer to customer. So for the diversity of QoS requirement, somewhere 5G is taking care, but still the requirement is going to be catered, because the capacity is going to be increased massively till 2035. So we have to take that particular target into the requirements into our mind, and we have to set a goal. What type of connectivity is basically required for this? Basically, when we look into that latency and reliability of 5G networks, then we can say the relation of tactical internet on the network control open up. That's why if we talk about the reliability from 4G to 5G, it has been improved, but not improved as per the expectation of the customers. Still, a lot of you can say threats are available with the network control, and we have the new challenges when we look into the latency, especially the delay. When we talk about the latency, means we are talking about the delay. So when we are talking about the delay, because n number of devices are basically increasing, and these devices, if it is increasing, it affects the services because a number of messages are to be delivered on time. That is the basic requirement, and lot of latency you can find. Latency is still there in the 5G, and this is a challenge, and we have to look into that particular aspects also. Now, if we talk about large massive network, means it is not only the mobile communication, it will be have n number of communication, n number of small communication that will be put together to create the ultra dense network, which can, we can say that cellless, or we can say wireless networks. Now the concept of you can say ad hoc networks, which started in around 2000, it has been basically increased. Now the ad hoc networks, cell networks, and wireless network will be clubbed together in one network, one massive network, and we have the multiple input and multiple output concept that will be there, and the breaking in this is we have to club it together so that all device will be enabled to take care of the entire. If you can see the graph, the worse UE basically, if we can use it, dense network is there, and the performance, if you can see how it has been improved with number of antennas, but still we require the less number of antenna to be put as an infrastructure, and the communication should be more secure, or it will cater the entire capacity of the world. So this is the biggest challenge in front of us. Now, if we talk about the second enablers, that is the main important thing is device to device connectivity, which I have already told you. Although right now we are connected with device with a particular tower. Now, device to device means we are talking about the ad hoc networks. There is no need to basically depend upon the towers to communicate with the another network. So it is better that we should make a small network as a dark network, and it will basically connect the entire device to device connectivity. It is a smart catching mobile set which basically balance the load opportunity. So this is the first challenge. If we look into the entire graph, if you can see, I have quoted, this has been published in IEEE Transaction of Wireless Communication in 2015, and what author has suggested that basically looking into the overlays and underlays, they have basically suggested that we should have to be independent on the networks, towers, and we should connect device inlays. Means anyhow device is connected to direct device via some communication network. It should not be Bluetooth, because Bluetooth is one-way communication, or we can say it is connected to only one device. We cannot connect with multiple devices through Bluetooth. So we require to take care of such a technology, which is, we can say, infrastructure less technology, which can connect the multiple devices together at a time. So that type of devices is required to be built, and that type of devices required to be generated. So this is the another enablers. Third enabler says man to man, because there are massive number of low rate devices that features the IoT, or we can say plethora of diverse scenarios, which very low latency data transfer should be there. Like if you can see the example, suppose in a particular holiday, or you can say in Diwali or in New Year, if you can see a number of communication has been done, means it is an almost infinite number of communication you are doing. Reason being that you are missing someone. So what is the problem you are facing? There is latency in the data transfer. Sometimes data get lost during the transmission. So this should be taken care by using man to man, or you can say person to person, or massive number to number communication sequences. Now, if we talk about 5G and your design of the architecture, if we can see the entire picture, what connectivity we are basically enabling. In this, we are enabling the tablets, IoT devices, man-to-man devices, and your personal devices. All are connected to it. They are communicating with each other. Means the entire user develop home infrastructure such as wireless router, internet access, femto cells, all are connected together. Femto cells are basically for the small area network. It is connected with one tower, and basically all these towers, these all small femto cells are connected together to make a big network. So such type of gateways are basically required, and that is already existing in the 5G. So looking into these requirements, we have the architecture, we can say different type of application requirements are there, and these requirements has been catered by 5G, because in 5G we have uh, general purpose hardware which will be available as a device. We have the all system functionality, baseband processing, video resource scheduling, and network routing. These facilities are already available with us. Apart from that, we have the energy efficient network scalability is available. So that's why we can say it will cater the entire application. Similarly, we are talking right now about the 5G. 5G is basically running on the gigabits. We can say 10 gigabits or maximum up to 300 gigabits, not more than. But when the entire population goes dense, now the world, completely now it is the population is generally increasing. There is huge requirement of, you can say, the catering of capacity. Second one, everyone want fast data download. So it is only possible when we will have to shift from gigabits to terabits or terabytes. If we talk about terahertz frequency, definitely we have the inherent support for large dynamic range of novel uses, and we have the cost-effective and flexible provision for high-speed data connections, which guarantees during the digital divide, which extend the fiber optic system QoE and performance reliability of the wires. So this is the expectations beyond 5G. So how it can be taken care? Basically, we have to bridge the gap of terahertz, and we require the ultra band and extremely directional wireless links, because still there is a problem of call drops. So until unless we don't have the directional wireless links, it is not possible to stop this particular drops. We have the we require the low absorption loss. We require the attenuation with distances goes low as much possible as it is. No, n number of things are required to be taken care. That's why we require the 6C combination. Now, the basic thing, 6C. Now, before designing the 6C, basically a draft has been constituted at IEEE in around 2014 to make a draft for the 6C communication. In, so they have fixed some goals. Then they have made a roadmap for 2030 and in the future, what will be the how basically 6C will land. What are the architectural aspects which required to be catered to implant this 6G communication? That is very, very important. Now, Another one is the network and connectivity features. Suppose if we switch to 6G, what are the features available with the 6G? Why we should go for 6G? Now, key performance indexes and we can say the spectrum and physical layer, what changes are required in these areas so that we should adopt the 6G communication. Now the next and final issue is the network and connectivity research challenges, which is still there in the 6G communication while testing the 6G. Now looking to the graph, I've already told you that we have started our journey from 1G communication with around 2.4 kbps. Now we are at 6G communication with kbps. The main expectation is that terabits per second communication should took place in the 6G. So we have started with the simple voice calling with 1G communication in around 1980. Then we have shifted to 2G communication around a decade, after a decade. It is around 1990, which
Excuse me, sir.
includes the yes.
Sorry for the interruption, but sir, your slide is not moving. It's still on slide number 2, presentation.
Oh, sorry.
Meanwhile, I have an announcement for the participants. Participants, please be ready for the group photograph that is scheduled to be at 11:30 a.m. Thank you.
Now, are you able to see?
Yes, sir.
It is slide number 14.
Yes, sir.
Okay. So when we look into the shifting of 1G communication to 6G from 2G, which basically caters the 64 kbps, it includes the SMS while incorporating the voice calling. In 3G communication with 2 Mbps, they have incorporated the internet with voice and SMS after a decade. Again, after a decade, the IOA application, Internet of Application, has been incorporated in 4G communication with 100 to 1000 Mbps. Now in 5G, which currently India has this particular 5G communication. Okay. In some of the areas, we cannot say in all the areas, but still in some of the areas we have the 5G communication, where the massive broadband and Internet of Things (IoT) has been basically connected with. Basically, the requirement of 6G is abruptly changing. It is not only the IoT, but it is apart from all the communication, we require to cater all the communication devices plus all type of automations should be connected together to make the entire world handle. For that, the requirement is the new spectrum, destructive technologies, cellular networks, then aggregation and visualization. In this, we have the AR, VR is there. Then we have the energy efficiency we require, and we finally require to basically take care of the artificial intelligence, and somewhat in some portion we can say machine learning and AI is also. Now, if we talk about the 6G, basically today we are in the 5G and we have some limitation, means the future needs, which I have already discussed. Because in 2055, I told you that around the entire population is going to be doubled from 2010 to 2035, the entire world. So we are required to take care of that particular capacity as well as everyone requires everything handy and it should be downloaded or we can say we can reach to any information in fraction of second. So this is our requirement. For that we require the 6G communication. Basically the 6G communication, the basic goal is the novel network demands especially the ultra high reliability, high capacity, efficiency, low latency. This is the basic requirement, or we can say goal of the 6G communication. Now, what we are integrating in 6G? Because right now we have uh, aerial, terrestrial, and maritime communication is there. But in 6G communication, we are going to integrate the space also. Means entire space communication, aerial communication, terrestrial communication, maritime communication, that should be connected together, and we have the n number of data sources, resources that will be available. Then we have the large range of application and services like
वेलफेयर की नहीं
augmented
आए
reality.
हाँ
Yeah, I'm getting some voice. I'm getting some voice. Is it okay? So, augmented reality and holographic telepresence like teleportation, e-health, preservation connectivity, Industry 4.0, and robotics, unmanned mobility, because UAV. This is basically the new concept. Generally, we are using it, especially in the defense services, as well as catering to the different applications. Also, we require the UAVs, and new devices are replacing the smartphones. So these are the large range of applications and services which is required in the 6G. And telepresence is basically the high resolution imaging sensing is there, wearable devices is there, wearable displays are there, mobile robots, drones, UAVs, specialized processor, distributed AI, haptic communication, and automated connected device. Take human-centric devices, bio Internet of Things, nanotechnology, everything should be connected to it. So the open resource issues in the 6G network and connectivity is ki what should be the architecture of the lower level physical layer 2 and layer 3, and what are the also the higher levels, what modifications are required in this. So this is a big challenge, and we are required to look into these architectures and technologies. Now, if we are shifting from 5G to 6G, what could it look like? Like evolution of hyper-connected world is there. Uh, if we talk about evolution of hyper-connected world, means an automation surges and uses of virtual reality express the need of faster and more secure communication as the goal. Now, hyperconnectivity, the trend towards online work and communication has been increased. If you can see, last 2 years, the last 2 years, due to this particular pandemic, everyone depends upon the online communication, and it has basically accelerated due to the global pandemic. Not only the pandemic, in future also it is going to be increased, because now most of work, especially the entire world, is basically going to be an online. Entire companies, even the industries, has moved to the online working. After the work day is over, people switch over video calls to online gaming, from virtual reality games to massive multiplayer immersive experience participations in the online games. It is really becomes the, you can say, day-to-day life activity. If you can see the changes in last 2 years, most of us is basically dependent on the online communication. Not only communication, gaming, whatever is there, all entertainment thing we have basically. Earlier we are basically dependent on the TVs, okay, and DVDs. Now Netflix is there, Hotstar is there, and a number of, you can say, uh, service providers are there. Those who are providing the entire service online. So we are basically depending on the online things. So this hyper connected world, this evolution in last 2 years has completely changed the mindset of the entire world. So this becomes the reality and this becomes the challenge for us how we should take care of it. So that's why we require to move from 5G to 6G. This is the first point. Now if we look into the 6G faster than fast, definitely everybody wants that. Nobody wants to wait for downloading a particular data. Everyone want that within a fraction of second the data should be online and it should be in front of you. So for that, the 6G revolution has focused on how to connect and control the billions of machines, micro to macro to nano in our digital futures. The 6G standard has truly been the next generation communication standard. Two key drivers for building the 6G are increased speed, low latency, especially the 5G that allows us to download the movie in under a minute. But 6G brings this possibility to download more than 140 hours of movie in the same minute. So just think if we shift from gigabits to terabits, definitely what change you are looking for. Basically, we are looking for the faster technologies which can download much material, or we can say n number of materials which we are currently downloading in a minute. And suppose we are downloading you can say 100 GB in a minute. For I'm taking it simply an example. Now in 6G, what are our requirement is around we can download 100 times of this whatever we have downloaded in a minute. So for that, we require the technology which can cater this particular thing. Especially if we look into the business world, the power of 6G will transform the entire way we work and we live. Think of having the high fidelity mobile holograms at the touch of the button, allowing us to converse and co-workers if we sitting at the same table. So apart from this, especially children, they are basically more habitual for the online gaming. And competitors can also be transformed into the truly immersive extended reality platform. They have provided us online. Even in most of the persons now they are basically shifted from local watch to the smart watches. So this is smart wearable, smart headsets, smart implants. All these things comes into the reality when 6G become faster than fast. The next point, which why should basically shift from 5G to 6G, is the massive leap forward. 6G will be massive leap forward in performance even compared to the new 5G networks. As we know that it operates on terahertz band. Currently, we are basically working on the 100 gigahertz to 10 terahertz, but it will have several terahertz. It operates on several terahertz, and the peak data rate is 100 Gbps in the air latency, lower than the 100 microseconds. But 6G will be 100 times faster, reliable than 5G. So with this kind of speed and power, it is hard to say that exactly what the 6G architecture will look like. Early discussion, if we can see the entire discussion in the entire world at the research paraphernalia, we can see the entire research is basically driven to the advanced level of automation and connectivity, which 6G is going to provide. So we have a massive leap forward. Then we are coming to the next item, that is the navigating 6G hurdles. then we can see that we have a number of challenges to overcome the designing of 6G extender, especially the implementation, because it requires the high spectrum pass loss, it requires the high computation requirements are there. Then we require a number of massive real-time information. So these challenges are required to be collaborated openness with cloud technology, and we are required to resolve it with a number of, you can say, computation techniques. So this navigation has a number of hurdles, but we require to cater all these hurdles. So before shifting to 5G to 6G, we are required to take care of the this particular point also. Now the last point in this is, when will 6G arrive? This is the biggest question, because right now we are not fully equipped with 5G, and currently we are mostly focused on, and we have the attention on the 5G only. So how and when we will come to the 6G? Definitely, CG we have cater up to the 2000. 4G definitely it has catered us by 2010, and 5G has catered till now. Means we can say by 2021 we are in 5G. Now, if we can see the entire trend from 1G to 5G, every 10 years the generation is going to change. So now in the next 10 years, probably around 2030, we are equipped with the 6G. So this is the prediction, a type of prediction, because already tests are already gone, already has driven at two different places in the world, that is in China and US, and now European Union has basically making it test bed in the small town, and they have found a number of effects are there. So they are capturing all these things, and then they will come with the final solution. And we hope that by late 2025 or 2026, 6G going to be a reality, and definitely we will shift to the 6G communication. So these are the different, we can say, shifting paradigms from 5G to 6G. Okay. Now, right now we are taking care of the 5G, which is basically third generation partnership protocol is there. So from 2030 to how we can shift to 6G, uh, basically there will be a number of, you can say, roadmaps are required to be built. The first, right now we are in the 5G. Now after that we should move with the 5G Cebu. This Cebu is basically take care, which is basically we can say fifth generation new radio band is there, which works on around 52.6 gigahertz to 250 gigahertz. It works between that, and we have the 5G non-public network will be there, and we have the new radio for light extension is there, because most of the communication took place through the, you can say, optical devices. So these optical devices has to be more extensive, and we have the non-terrestrial network also. We are required to take care of the non-terrestrial network also. Apart from that, we have the RAN data collection. Basically, radio access network we could multiply with AI and ML. So this, by the end of this year, probably we are able to achieve it. If not, probably by 2022, we are able to achieve the 5G SIM. Because research has already been over, basically implementation part are left, and very soon we are going to basically come to this particular. Now again from Cebu to 5G Mevo, if we can move, definitely the 5G Mevo, basically new radio, you can say, if we look into this, we require the new radio link that basically work from 250 gigahertz to 500 gigahertz. This will basically take care of all the flying use and the uh, flying user equipments. Means generally when we are in the flight, generally we are not able to communicate because it has been told in the flight that we are required to either switch off our mobile or we have to go on the flight mode. Now by 2025, that will be possible that while flying, we should have the connective equipment and we are easily able to call in. Then we have the joint sensing and communication is there. We have the brand full duplexing system is required. We have the fusion of AML in C plane and U plane. Means U plane, if we can take this is the user plane, that will be available. Means a number of, you can say, things has been basically incorporated by 2025 or 2026. So this we have called, or IEEE has named it as 5G MIB. Now by 2028 or 2029, by the end of 2026, we are going to enter into the 6G with 5G level. It is basically 5G level, and we are going to enter into 6G. In that, the communication, the new radio network has been basically redesigned to operate on the 500 gigahertz to 1 terahertz. Now, most of the devices at that time, right now, we are required to cater the entire device through the battery. At that time, batteryless devices will work. We require the support for the energy harvesting and the wireless power transfer. And wireless fusion with AI and ML is required with new change in the layer of the physical layer, and we are required to basically redesign the layer 2 and layer 2. The integration of communication like sensing, imaging, radar images, everything should be basically clubbed together. Right now, it has the different way of communication. Now, cognitive integration of across the evolution of new radio, Wi-Fi, Li-Fi, light fidelity has been already invented earlier around 1990s, but still it is not in the function. But by the end of 2025 or 2026, the new light fidelity becomes the reality because most of the communication took place through the life. So these are the things which has been predicted by one of the author in electronics, that is the SCI, one of the SCI journal, and definitely for the 5G Savo, research has already been completed. Now equipment are ready to be deployed, and simply we are moving from 5G to 5G Savo. 5G Mevo research is already going on. Still research are in place, and until this research cannot be complete, I don't think it is possible to make it. So there is a big challenge when we are moving from 5G to 5G Savo to 5G Mevo to 5G Levo to 6G. So there will be n number of things we require in it. Definitely for the networking and connectivity, for architecture innovation aspects, we have a number of enabling technology which required. What are the potential requires in that particular area? What are the challenges we have with the architecture? So these things has been basically given by one of the author in IEEE Communication magazine. First enabling technology which required in this is the multi-connectivity and cell-less architecture. Right now, we are basically dependent on the cell. Each cell has some limitations, some you can say geographical areas required to be defined. Within that, we are basically communicating with each other, and major the cell will connect to the another cell, and they are communicating with each other. So this is the current concept. Now, if we don't have the cell, Means we don't have the tower, we don't have the infrastructure. So we are required to make such a network which can connect a person to person, or we can connect a device to device. So this is the biggest problem, and this requires one and only when the integration of all different kind of links should be connected. This is a big challenge. Second challenge, certain enabling technology is the 3D network architecture. Obviously, we require the seamless services. So for that, we require the 3D coverage. So for the entire 3D coverage, we require the special technology which can cater the 3D. Disaggregation and visualization, there is massive use and dense deployment of, we can say, the low cost of operators. We need this disaggregation and visualization. N number of players are there, N number of operators are there, how they can club together, how they should be integrated together. And although it is doing in the 5G, it is doing in the 3G also, it was doing in the, you can say 4G also. Okay. But still, n number of operator with n number of technologies, how they should collab together. So this is the biggest problem we have. Now next point is the advanced access backhaul integration. Obviously, we are required to integrate indoor as well as outdoor devices. So how we should basically take care of what type of technology is required to connect all this. Now by 2030, I think energy is becomes the biggest problem. So the next enabling technology which requires is the energy harvesting and low power operations. For that, we are required to shift something from battery to somewhere else. So we are required to call for the different type of research. So how we can switch from battery to something which is not dependent on something. Okay, for the energy consumption. So this is the enabling technology we require. For the intelligence in the network, we require the learning values of information, knowledge sharing, user-centric network architecture. The challenges before us is the scheduling, modeling, high performance, scalability, and naturally need to integrate the entire sources. Complexity is there. Need to design the novel sharing, and we require the real-time and energy efficient process. So these are basic requirements which require to be catered, because this is really a big challenge. See, what type of scenario we are going to cater? First is we have the undersea network. So currently we are able to communicate with the undersea with the terrestrial network in the 5G. But in 6G, what are our expectation that we should connect from undersea to terrestrial, terrestrial to aerial, area to space. A person in the space can easily able to communicate with the undersea networks. So this is the basic requirement. How your satellite will connect to the aerial, they will connect to the terrestrial, they will connect to the undersea network. This is a big challenge. So these challenges is required to be catered in the 6G networking and connectivity. In two different papers has basically defined how basically we are going to connect with directly with the satellite, with aerial network and terrestrial network with undersea network. So these things are really a big challenge in front of us. Right now, three-stage communication is already available. But integration of all three are totally different. Terrestrial network is communicating with undersea, but right now we are not able to communicate with undersea to area. So for that we require the terrestrial network, support of terrestrial network. Aerial network is basically connected with the space network, and we can say terrestrial is also connected with the space network, in direct communication took place, but they are not able to communicate with the undersea networks. So these are the big challenges which require to be tackled. Now, if we look into the networking and connectivity, what we require is a nano networking, we require the bio networking, we require the optical networking, we require the 3D networking. Nano networking, if we can say the IoT, see, now most of the thing is going to be an IoT based. All are becomes the automated. Like even if you are sitting in the office, suppose if you want that, you should switch on your car AC. You can do it very easily. Do it, but this is possible in the 5G communication. But if we want to operate something, if we want some data from the space, this is not possible. For that, what we require is that a small communication that should take place between the terrestrial to aerial to space. So, nano networking is going to play an important role in 6G networking technologies. With different materials, with graphene and metamaterials, we are required to design the nanometer range devices for this. So this is very important because physical design are required to be modified. It should be a molecular communication which is really a challenging task. Right now, currently we are working mostly on the metamaterials. Now we are required to shift from metamaterials to something else. Because we are required to build a nano networking also. Bio networking. This is very important. Now, entire body. If we look into the body of the human being. Now, what is going on inside our body, we don't know. But using the bio networking, or so we can say bio IoT, yeah, bio automated devices, we are able to take care of the biological cells which is used to communicate with that. Suppose a person, something is going wrong in their body, until unless body shows some reaction, he or she is not able to identify what is the problem. But using this bio IoT devices, we are able to identify these things. And it should be communicated to the nearest hospital, it should be communicated to your doctor. So that doctor should take an initial step to basically stop all these things. So this is the bio networking is required. The novel routing scheme is to be developed for biological IoT and nano IoT compared with the IoT. Currently we are running with the IoT where by simply our mobile we are basically running our fan or switch off our fan, or we can say switch on our, you can say AC at home, or switch on our AC at you can say parking while sitting at the office. We are required to go beyond that. So effective nano devices and you can say architecture is required to build the nano networking as well as cloud networking. Next is the optical networking. Currently, we know that most of the communication took place through the optical networking. This also helps in the 6G communication. But still, in some of the villages, still the you can say the optical fiber communication is still not there. They are required to build it. In some places, in the difficult areas, even in the sea, also we require to build it. So this is the thing we require to take care. Next, very important thing in the 6G is the 3D network. Why 3D is required? Because right now drones are basically friend to us, as well as it is enemy of us. Because by drone we can easily cover a small area where we can identify anything. The drone-based user devices and drone-based station, they are basically able to communicate with each devices. For that we require a 3D networking. Now novel modeling for including robust. Currently what happens? Generally in the drones, the communication took place in the one. Okay, it is not a number of communication took place by the single drone. So here drone can be controlled by the space also, drone can be controlled by sea also. So this type of technology only we are able to build one and only when we are basically enable the entire city. So if you can look into the networking connectivity from 5G to 5G SAVO, MEVO, LEVO and 6G comparison, if you can see, so you can see the requirements. What are the key performance indices? What are the density? What are the spectrum? What reliability, latency, energy, mobility and positioning is required. If you can see first to graph from left side, the first graph of the left side, we can see where what are the area traffic capacity, what are the density, what are the user data, what is the peak spectral efficiency, what is the peak data rate, bandwidth, spectrum. Starting from 5G to 6G. It is not 5G level. 5G level is basically entering into the 6G. Now, user data rate, if we can see, first of all, we are required to see the area traffic capacity. Per square meter, how much megabits per second you require? Currently, we require only 10 Mbps. By the end of 2030, we require around 200 Mbps as our capacity is going to increase. Similarly, the density, if we look into the devices, per square meter is currently we are approximately 1. How it is lesser than 1 currently? By 2030, the density becomes around 2 devices per square meter. Just see the requirement. It is going to be done in next 10 years. Now the user data currently we are if we are using 100 Mbps right now, by 10 years we require around 200 Mbps. And bits per second, or we can say in hertz, if we can say peak spectral efficiency, currently we have 30, we require 60. Similarly, if we talk about the peak data rate, currently we are having 20 Gbps, and by 2030 we require 400 Gbps. Currently we have 0.5 gigahertz bandwidth. We require 10 gigahertz bandwidth. Similarly, a spectrum has been increased from 50 to 1000 gigahertz. See the changes within 10 years. What are the tremendous change you can see in the computer? Similarly, if we talk about the reliability, latency, energy, mobility, everything you can see, the reliability right now, if we take reliability in the communication, out of 9, around reliability level is around 5. But what our expectation is 9 out of 9. We should going to achieve it by 6. By 2030 we are going to achieve. If we look into the user plane latency, what are the delay in millisecond? Currently we have 1 millisecond is the delay generally if we are transferring the data in the 5G communication. But when we move to 6G by 2030, generally the user data latency should be 0.1. This was the delay. Just think how we are going to change the entire communication paradigm. How we can shift it. If we talk about the network energy efficiency, the gain should be right now is around 25, 26, around that. We expect around 100% gain, which is only possible in the 6G communication. Earlier, it has been told that in the ATM asynchronous transfer machine is there. Okay, if instead of TCP/IP, if we are able to adopt that, we're able to achieve the 100% network energy efficiency. Is it going to be possible in TCP/IP also when we shift from 5G to 6G? So this is the biggest challenge. Terminal efficiency increased from 30 to 100. Similarly, mobility increased from 500 km per hour to 1000 km per hour. Similarly, position accuracy has become 1 centimeter. So, if you want to track some person, where is this person? Currently, the map is giving you the location. At this location, you can find that particular people. You can find that particular device. Now the accuracy of that is around 100 centimeter, means beyond 100, in the circle of 100 centimeter you can find that particular person. But the exact position we are required to find out by using the 60 combination, and it is possible by 20. So if you can see the changes from 5G to 6G, from 5G Sebo, Mevo, Levo and 6G, the entire form is going to be changed. So this is not a prediction, it is going to become a reality, because a lot of research has been done and test beds are already going on. More tests are going to run and they are going to deploy in several towns. After that, maybe they will cover the entire country. And by 27, 28, by 2027 or 28, we are going to basically deploy it in the entire world. So, if we talk about the 6G networking and connectivities, the main key performance indexes are connectivity, obviously, remote controlling, experience area, everything we require. Now, if you can see what are the changes you can find here from 5G to 6G, from AR/VR to televisions to remote control to connecting everything. A lot of changes there. You can see that particular change in the graph, where network management latency and reliability and capacity has already been done. Now capacity is there, but are we able to utilize that particular capacity? Right now in 5G, I don't think we are going to do that. But definitely in 6G, we are able to capture the entire capacity. Whether it is the experience sharing, remote controlling, or connecting everything, whatever it is, the cases are basically different application will be clubbed. If you can club together, definitely from the point of view of the communication, 6G is very, very. In 6G, around 99.99% reliability is there. Around the vehicle speed of 1000 km per hour can be clubbed, or you can say taken care by the 6G, which currently in the 5G communication around 500 km per hour is taken care. While if we talk about the energy efficiency, around 100 times more than whatever is the energy efficiency of 5G. If we want to know how much devices are connected at a time, in 5G it is 10 to the power 6 connection per kilometer square is basically the density is there. But in 6G it becomes 10 to the power 7 connections per kilometer. So see the change. This change happens one and only when we will reach to the. So starting from low mid bands to visible light range from 6 gigahertz to 800 gigahertz, it becomes possible in the 6G. It will cater the entire devices which covers from sub 6G to 800 gigahertz. It has ultra massive MIMO, multiple input and multiple output holographic radio is there. Beam performing using the beam spaces paradigm is there. Holographic radio is there. Integrated access and backhaul, space terrestrial network, broadcast and multicast network, it will cover. Now, if we look into the key performance indexes from peak data rate, experience data rate, peak spectral efficiency, experience spectral efficiency, bandwidth, capacity, density, efficiency, latency, reliability, jitter, and mobility. You can see all these key performance indexes. Definitely 5G is lagging behind the 6G. Because data rate tremendously it has been changed from 20 Gbps to 1 Gbps. And the mobility basically improved from 500 km per hour to 1000 km per hour. Latency is there. Jitter is not defined in the 5G because it differs from device to device. But in 6G, it is 1 microsecond already defined for any devices. Reliability is too high. I have already told you we are going to get 99.999%. This much reliability we are going to get. So similarly, if we can see, there is entire change. In 5G currently we are using 6G, and in 5G basically we are looking around 6 gigahertz. But from 6G we are basically cater from 6 gigahertz to terahertz, 800 terahertz. So definitely there is a lot of change is going to happen in this 6G. Now the major topic is what is the topic of research. Currently, research on 6G is already going on. I have already told you that it is already going on. There is the biggest challenge before us. The major challenges which requires the focus on research, especially on the hardware complexity. Then variable radio resource allocations, then low power circuits with high performance capabilities. Then we require the pre-interface scheduling and massive connectivity. Then we require dynamic radio allocations, seamless coexistence of multiple wraps. Then we require the security and privacy and AI-based management and control. If we can look into this, this is the biggest challenge. Because I think around more than lakh of researchers are basically working on that. 34 companies in the entire world is working on these research topics. Because still these are the challenges in front of us. Now first challenge, if we talk about, that is the hardware complexity, increased hardware complexity. Basically, the next generation mobile communication required to integrate a lot of multiple communication devices. Okay. Ranging from sensors to high definition video transmission devices. And number of devices are there. So all these are required to basically integrate. Whether it is the high speed trains are there, airplanes are there, everyone required to integrate. So such devices will require the variable packet size to be transmitted. Because everyone cannot transmit the same packet size. Variable packet size is required. For that, we require to look into what type of device, what type of things we require. Because chip size is going to be increased. If we require to cater all the communication, all different variable packet sizes, everything we require to cater, then what we require is we require to increase our chip size. Now once chip size has been increased, what happens? The device size will increase. This is the biggest problem. With the variable packet size to be transmitted, the hardware complexity naturally is going to be whatever communication device we have. Either it is a mobile, it is a PDAs, it is a laptop, it is a, you can say whatever is there. So how we can take care of this? Because it must select its signal processing RF chains according to the incoming packets, which means that the chip size definitely going to be increased. Ultimately, the mobile size increase, ultimately everything, whatever devices we are using currently is required to increase. This is the challenge. But how this challenge can be taken care of? So basically, we are required to look into the larger bandwidth from 3 gigahertz to 60 gigahertz, okay, even up to terahertz. For this, we require to basically develop a chip, okay, which has a number of complexity, but still the size we require to reduce. Otherwise, if we can increase the size, definitely it does not solve the problems. So this is the biggest challenge, and research in this particular area will really, I think, appreciate. Next important point is we have the low power circuit with high performance capabilities. Hence, low power circuit, high performance processing capabilities are required to cope with the latency. Critical scenarios such as automated cars, medical or health applications, communication needs in a very short duration of time. To attain the latency, only few milliseconds is quite challenging because in health we cannot compromise. Suppose automatically a person with you can say low blood sugar, automatically his blood sugar goes low. So we cannot compromise on time. These are the medical emergencies. Similarly, a number of cases are there. So to cater all these, we require to fix the priorities. For that, we require high performance processing. To attain this particular criteria, uh, only a few milliseconds is quite challenging. So, achieving this, we require low latency, ultra high reliability devices or processors, which consume low power. So, these things we are required to. This is really biggest, you can say, research challenge with us. The next challenge is being faces scheduling in massive connectivity. Suppose I have already told you the size. Suppose 1 meter. Currently, we have one devices. Although it is, if we can look into the entire scenario of the world, uh, around 1 meter, it is around 0.37. This much device is available per meter. If we look into the geographical area of the world, but by 2035, it is going to be around two, and two device each at every square meter. So how we can cater this? So for that, in wireless communication, a network node assigns the radio resources to other nodes. So the massive number of devices will connect it to each other, setting the priority level for each devices, maintaining the latency, packet loss, requirement of 60. It is really very challenging. Then we can say it is the another research field with appropriate algorithm we require to develop so that we can basically schedule the massive connectivity. Basically, now next points. Hello. Yes.
Okay.
Are you getting my voice? Okay. The next biggest challenge is the variable radio resource allocations. Now we know that everyone everyone requires every different quality of service. The quality of service requirement are different for different people. Variable quality of service requirements are there. So how we can cater that? So definitely we require a variable radio resource uh, that has been assigned to the user. Means with variable bandwidth, power, and we can say various, uh, you can say n number of key performance indices, we require to design a variable radio resource to how it will allocate the services. Another challenging aspect of 6G is that with propagation frequency, the signal can attenuate rapidly and high penetration loss is there with high frequency. So how we can take care
ಆ
of it?
ಚೆಕ್ ಮೊದಲು ಕ್ಯಾಶ್ ಆದ್ಮೇಲೆ ರೆಸಿಪ್ಟ್ ಕೊಡೋದು, ಅವಾಗ ಅದನ್ನ ಇಲ್ಲಿ ಎಂಟ್ರಿ ಮಾಡ್ತಾರೆ ಅವ್ರೆ.
Yes. Okay. So the important point is how variable radio resources can be allocated. The signal is also automatically attenuated upon assessing the houses, residences, workplaces, or you can say space even in the sea also. N number of disturbances are there. So increasing frequency, the radio waves gets attenuated. It could have the trouble in penetrating the walls, the buildings, houses, even in the sea propagations also. A number of disturbances, a number of you can say different animals are there. So for that, a disturbance is already there. So to the great extent, we can say to develop such a suitable, fast, precise algorithm is required for allocating the variable radio resources. So this is an important point which required to take care. Now next is the seamless coexistence of multiple RATs. Uh, Means if we talk about the multiple interfaces, because we are not only able to communicate with our mobile devices, we are able to communicate with a number of devices. We don't know what type of devices we are currently using, but a number of devices we are going to use in the 6G communication. Then the incorporation, it requires a multiple RATs. That ensures that CG, basically 6G will coexist with interoperate with different type of technologies, because only currently we are using the mobile technologies, and you can see computer can communicate, computer via internet it will communicate with the you can say mobiles. But if we want to connect n number of communicating device with all the devices, we definitely require to cater seamless coexistence. For that, we require to take care of the different technologies like Wi-Fi, Bluetooth, hub, sensors, IoTs, automations, whatever it is. For the change in the user radio environment, the air interface can dynamically change due to this resistance. It is still, we can say it is an open challenge to develop a scalable technique that guarantees interoperability with these devices. Because key performance indexes are required to be met, and we are required to take care of the advanced technologies. So we can say 6G is going to play an important role while
ಹೌದಾ?
security and privacy also. While security and privacy also, we are going to achieve around 99% security. So this is, we can say, biggest challenge for us to develop this type of system.
ಹ್ಮ್.
Currently, we are using AI-based management and control system with different applications, but it has not so far has been developed for the networking and connectivity. We are required to design that also. So these are some of the challenges in front of us. We have to look into. We have to tackle. As I have already discussed, these type of challenges we have basically put it into different sections. What type of architecture is required, what type of networking dimensions are required, what are the potential technologies which we can use, what are the cases we have, what are the key performance indices will be, what are the research challenges. If we can club all together, we can see still we have a number of challenges. And the biggest challenge which I have not discussed in this the entire presentation is the challenges before the persons, challenges before the living things. Because we are going to use very high frequency. On that particular high frequency, what are the biggest challenge to the environment? What are the biggest challenge to us is still questionable. Right now it is in the testing phase. I hope that within 2-3 years, we are able to achieve and we will succeed without affecting the environment. We will achieve the 60 coverage. Thank you very much. These are some of the references are there. Any questions, any queries regarding this?
So I request participants, if they have any queries, you can ask from our expert of today. Okay, I would request Ashi to say a few words for sir. And request participants to switch on the camera for our group photo.
I would like to thank Dr. Sandeep
Just,
sir
just
for
wait,
his
just,
insight.
just, just wait. Actually, I have received one question. The question is, without much modification in the 5G, can we achieve the 6G? No, it is not possible. Because suppose our aim is to get the seamless technology, our aim is to get, you can say, fastest technology. Definitely, we require to change and modify the entire device. Second thing is our communicating devices not basically you can say used to communicate with the different type of devices. Only we are able to communicate with our systems, our tablets, our mobile devices, our PDAs, but we are not able to communicate directly with you can say that other seamless devices like in air, like in sea. We are not able to communicate with. So for incorporating all these things, definitely we require to incorporate several things. Okay, we require to incorporate a different type of technologies. Thank you. Thank you.
So there are queries in the chat also.
Okay. Next question is about the antenna. What type antenna possible in the 5G and 6G communication? Generally, what we are using currently is the microstrip antenna. Generally, in the mobile devices and all other communication devices, we are using the microstrip antenna, patch antennas is we are using. In the future technology, and these basically these antennas are mostly made up of the you can say different type of you can say different type of devices which is mixed, and we can say it is Right now we are using the 5G technology, but for 6G still we require a type of you can say very small antenna. Okay, for that still research are already going on. We cannot predict what type of antenna basically we are going to put in the 6G for the communication devices. But I'm very sure that we are not going to use any infrastructure antenna. Any other question? Right now it is that today we have the concept of base station. At that time by 6G we don't require any base station for communicating with any devices.
I'm requesting everyone, please switch on your cameras. All of you, please switch on your cameras.
Sandeep, sir. Sir, can you please stop presenting your screen?
Yes, please continue.
I request all the participants to kindly switch on their camera. This is for the group photograph.
Shilpa ma'am.
Yes, sir.
Ma'am, please make the sir as a attender only instead of presenter, because still sir slide is there. Then all members are unable to accommodate on that part.
Okay, okay, sir.
Or you can make me as a presenter, then it will be, I think.
Now it's fine, sir?
Yes, ma'am. Just please wait 1 minute. I am taking some photographs. Yes. Thank you, everyone. For next session, we will meet at 11:45. Thank you, everyone.
Thank you, sir. Thank you so much.
Thank you, sir.
Again, we will meet at 11:45. By the timing, I think nearly 10 minutes are there. No need to go out from the meeting. You can stay in meeting and take a 10 minutes break. Thank you,
sir.
all.
Okay. Thank you, sir. Sir, can I get the question in WhatsApp group? Because net itself, it is, I think it won't be there evening.
You are talking about, sir, assessment test?
The test, yes, sir. Assessment test, because now itself it shows 50% alert and all. So I think evening I won't get that network problem. Maybe if you are putting in WhatsApp group, giving some time, then it is useful for us.
Sir, I will say actually the test will be on Google Form, and I will share the link in WhatsApp also. Don't worry.
Okay, sir. Okay. Thank you, sir. Thank you, sir.
Okay. Anything else you want to know about assessment test? Assessment test is having 40 marks and 30 minutes duration. You will find there is no negative marking, and the questions level will be basic questions will be there. You will find basic questions from optical and wireless communication, and it is having 30 minutes again. And make a note in your mind that duration of test is 30 minutes. After 30 minutes, automatically it stops accepting the responses. So please be careful about that one. And
Okay,
in the duration you will find any difficulty, please let me know.
Okay. Thank you, sir.
Thank you all.
Sir, we have to fill feedback form also now on ATAL.
Yeah, that part in validity session we will discuss, sir. On ATAL portal we will activate. I need to fill your attendances also. Your portal.
Sir. Done, sir.
Okay. Okay then. Thank you. We will meet again at 11:45.
Okay, sir. Thank you.
Yes, Simran sir, I have given you the rights. Good morning, sir.
Good morning, ma'am.
Sir, sir, I have given you the right.
So I need to click on iPad screen, right?
Yeah.
Start broadcasting.
Yeah, broadcast screen, and after that, wherever your presentation is, yeah. So now you have to give the link wherever your presentation is.
Okay, let me check where is my
This
presentation.
one, the
Here
high
is my
speed optical. Just double click over here.
notability.
Yeah. So now you just have to drag or just scroll for the next instructions. Sorry, PPT.
Slide. Okay, okay.
Yes, sir. It's fine.
I'm writing on my
Yeah,
screen. Is
it's
it
visible.
visible?
Yes, sir. It's
Okay.
visible. It's fine, sir.
Oh, actually, this is first time I'm giving presentation on my iPad.
Sir, same
Okay,
happened.
that's
Same
why.
happened with me the first day, sir. Same happened with me.
Okay, okay, okay.
Huh. Okay, sir. We'll start at 11:45, sir.
Sure.
So I welcome all again on the day 5, session 13. It will be taken by our expert of day by Dr. Simranjit Singh. He's working as an assistant professor senior scale at Department of Electronics and Communication Engineering, Punjabi University, Patiala. He'll be talking on the topic high-speed optical network for 5G and beyond. So for formal introduction, I ask Ashi to say a few words in Sir's honor.
Dr. Simranjit Singh is working as an assistant professor in the Department of ECE, Punjabi University, Patiala. He did his BTech from GNDEC Ludhiana in 2008 and has received ME and PhD in ECE from Thapa University in 2010 and 14 respectively. He has established an advanced photonics and optical networking research group lab in the Department of ECE. He has been awarded Raman Fellowship from UGC, under which he did his one-year postdoc from the Institute of Optics, University of Rochester, New York, USA. He has published more than 50 research papers in SCI journals having high impact factors. Recently, he has been appointed as associate editor of reputed SCI journal, IEE Electronics, and ESCI journal, IET Journal of Engineering. Dr. Singh has elevated to IEEE senior member in August 2020 and has been appointed as executive committee of IEEE Photonics Society, Delhi section, Rajasthan chapter. He has delivered more than 15 talks at national and international level and chaired many sessions. He has guided 1 PhD thesis, 2 are submitted, and 6 are ongoing. He has supervised 21 master's theses, and he has also worked for FICCI, Government of India, as host scientist under C.V. Raman Fellowship for African Researchers. Today, he'll be talking about high-speed optical network for 5G and beyond. We welcome you, sir.
Thanks for the introduction. Am I visible, ma'am?
Yes, sir.
Okay. So my presentation.
Not right now, sir.
Not right now. Actually, I don't find the option to share my screen actually. At that time, I have stopped my screen, but
Okay.
right now, I don't see any option.
Sir, just a minute. I'm giving you again a right.
Okay,
Sir,
thank
now
you.
just take.
Yes, I got it again.
Now it's fine, sir.
Okay, ma'am. So am I visible now?
Yes, sir.
Okay, thanks. Hello, everyone. So first of all, I would like to thank the organizing team of this FTP who invited me for a talk. So basically, I'm not giving any like expert talk. I will discuss the things which I have experienced in my career and which I have done in my research. So I will discuss few points about the high-speed optical networks for 5G and beyond. So basically, in this presentation, I will discuss that how the optical communication is beneficial for 5G and beyond. So basically, the optical communication system is used for front hauling in the case of 5G and beyond. 5G and beyond means 5G, 6G, 7G, and other upcoming technologies. So basically, the high speed means the bit rate. So how we can increase the bit rate in the communication systems? Okay, it can be increased by 2 ways. First way is capacity by increasing the number of users, and the second way is to increase the bit rate. So there are two type of bit rates. One is per channel bit rate, and another one is overall bit rate. Okay, so if I am using 4 channels having 10 Gbps each, and then the per channel bitrate is 10 Gbps, and overall bitrate will be 40 Gbps. So my research interest is broadly electronics and communication engineering. I have done my graduation, post-graduation, and PhD, and the postdoc is in optics. My specific area of research is optical communication networks. So why I have choose this area? I have around 14 years of experience in this area. Since my master's thesis, I am working on this area because this is open area of research. In other areas like wireless communication, antenna, and other different communication systems, you need to do something which is very high end, because those areas are already saturated at the international level, at the national level. Many things has been done. So in the case of optical communication system, according to me, only 20% area is explored. Still, there are scope of 80% that we can do something in the optical communication networks. So at that time, obviously, my master's in my PhD, I required publications. So because after having publication, I can get my PhD. So I choose this area because this is like very attractive to me. And secondly, there are many journals in this area that we can submit. Uh, so that's why I have chosen this topic. Another advantage, obviously, optical fiber has many advantages like large bandwidth, high speed, lightweight, small size, and it is immune to electromagnetic interference as well. But apart from the advantages, there are also disadvantages. Attenuation is one of the disadvantages. Dispersion is the disadvantage. Non-natives are the disadvantage. So, as far as the high speed is concerned, we need to take care about these type of disadvantages. So, in 2011, Professor Matsuka has predicted something about the capacity we need in the coming years. In 2011, he has predicted that in 2020 we will be dealing in terabit per second of speed. Okay, so nowadays you can imagine that in our home we are getting 100 GB of speed of internet. Okay, but surfing speed is obviously low because we are very like many users. But he predicted that by 2030, when 6G technology will come, the requirement would be 1 petabit per second, okay, which is very huge. So wireless communication can accommodate only like Mbps, or maybe somehow using advanced modulation multiplexing team, we can reach 5 Gbp, 1 Gbps, but not to the terabit per second, but not to the petabit per second. So obviously we would need optical fiber for that. Even in this case, like this is the 1 petabit per second in 2030. Optical fiber has only 220 nanometer of bandwidth. This is the bandwidth, effective bandwidth of the optical fiber. So in the 2020 nanometer, this is also not very big bandwidth. We got the speed in petabit per second. Okay, so we would need obviously the advanced architectures of the optical networks, advanced modulation formats, advanced multiplexing techniques to attain the high speed. So basically, why there is hike in the requirement of the capacity? Because the number of users who are using internet are increasing day by day. Our requirements are increasing day by day. I remember in 2000 we don't have much mobile phones, okay, but in 2000 like in 2015 we like everyone using the mobile phones. But the thing is, we actually changing the trend, okay. I am not a single user. Right now, I am using my mobile phone. I am using my tablet. I am using like smart watches and other smart electronic gadgets which are connected with the internet. So I am not only a single user. Basically, I am a five user. We can say that. Or for example, in average, I am considering that I am not a single. I am a five user. So you just imagine the crowd in India who are using internet. If we are considering that the 50% of crowd is using the internet, so you can imagine the 70 crore people multiplied by three or five. You can imagine that how much users are like using internet. Apart from this, the requirements are changing. So in 2011, we were dealing with the photos only over the social media. But right now we are dealing with the videos. Okay, we are more interested to see the videos, not the photos. So videos are required like high bit rate, high bandwidth. Okay, so in future we are talking about the holography. Okay, we are talking about the high speed online gaming. So we would need a huge bandwidth, or we would need the architectures or the like techniques so that we can accommodate that much requirement. Okay, so I'm not saying that optical communication network is best, because optical communication nothing without wireless communication, satellite communication. Because for portability, we definitely need wireless communication. For long distance communication, we definitely need satellite communication. Okay, so basically, for attaining the high speed networks, we can say that we need a hybrid network, hybrid structure of optical communication, wireless communication, and satellite communication. So the challenge is that how we can efficiently utilize the resources of optical fiber and components. Okay, we have limited bandwidth, which is 220 nanometer bandwidth. That how we can efficiently utilize this bandwidth, and this is the main we can say that issue nowadays, and it is also an open area of research. I have published many papers on this issue only. So as I told you that there is a changing of trend with respect to the communication technologies from 1G to 2G, 2G to 3G, 4G, 5G, and 6G will be there. And also, as you can see that initially we were dealing with the analog signal only, analog voice only. Then we are dealing with the digital voice only. But nowadays what we are dealing, we are more required the data signals. Okay, we are not actually concentrated about the voices. We are dealing with the data signal. We are converting a voice into the data form. Okay, and we are sending that through the communication network. So you can see that the requirement are increasing. Okay, with respect to the generations. Okay, in the case of 5G technology, we are dealing with the 40 Gbps of speed. Okay, this is the aggregate speed. But in 6G, the requirement would be in the terabit per second. Terabit per second is for one point-to-point system. If we will be talking about the overall architecture, then we would require terabit per second of speed. So this is the basic infrastructure of 5G technology. I have made this infrastructure as per my requirement, as per my research area. So there are three types of like sports, or we can say the hauling. One is front hauling, another one is mid hauling, and another one is back hauling. So basically, backhauling is can be accommodated by using the MIMO antennas, or we can say the massive MIMO antennas. One of my PhD candidate is also working on this area, which is backhauling. She is proposing massive MIMO, and we will be like going for the publication soon. Okay, so massive MIMO antenna can accommodate the backhauling. Okay, because in the backhauling we don't need that much capacity, but in the case of front hauling we would need a much capacity which can be provided by the optical fiber only. So, in my research, we are dealing with the and three of my PhD candidates are working on front hauling, and one of my PhD candidate working on massive MIMO back hauling, and another my JRF is also working on back hauling, and he is just dealing with the MIMO only. So basically, for back hauling, we can go for the massive MIMO, okay, which can provide the capacity to for the backhauling capacity to the backhauling network. And for front hauling, we would need optical fiber. Okay, so not only the optical fiber, we also need some like techniques. For example, the optical passive optical networks. Okay, the advanced version of passive optical networks. I will discuss in this presentation. This is the full spectrum access of the 5G technology. So as I told you, the trend is changing. Why trend is changing? Because more and more users are like coming day by day. Okay, new users are coming day by day. Obviously, if there is a huge number of users, we would need a high bandwidth. Okay, so in this case, in the case of 5G technology, we will be like having millimeter wave. Right now, we don't have 5G technology in India, but in China and USA and Europe countries, uh, they are using 5G technology. They are using millimeter waves, but there are advantages and disadvantages of millimeter wave. What the thing is, we have to go for millimeter waves because either we have to reduce the requirement or either we have to go for millimeter waves. But I don't think that we can reduce the requirements because we are totally dependent upon our electronic gadgets. Right now, we are using electronic gadget for the presentations. Okay, so we have to go for millimeter waves. Millimeter waves having some advantage. The big advantage is it provides high capacity and high speed. Okay, but in other terms, the disadvantage is that we can't transmit the data over the millimeter wave for long distances. Okay, that's why we are talking about the picocells in the case of 5G technology. So, one of my candidates is working on massive MIMO, which is like resonating at 28 gigahertz, and one of my PhD candidates working on terahertz waves for the 6G technology. So we are actually going far from the low spectrum, okay, because the low spectrum we already utilizing it. We have to go for the high spectrum. So if we have to go for the high spectrum, we need to propose some antenna designs. We need to fabricate, we need to test the antenna design. So that's why we are doing this. So this is the another basic architecture of the communication technologies. So basically this is front hauling and this is back hauling. So both can be used the millimeter waves. Okay, there is one technology which is called millimeter wave over fiber technology, which can be used for the front hauling of 5G and beyond. So millimeter wave over fiber means we don't need to convert the millimeter waves into the like electronic form, and then again we don't need to modulate that electronic signal over the optical carrier. We can directly modulate the millimeter wave um, over the optical carrier, okay, and can be transmitted through the optical fiber. This technology is called a millimeter wave over fiber technology. So this is a very emerging technology. If somebody wants to work on it, I think you should explore because publications are coming in this area, and also you can also file the patents if you have a new idea to in addition to the millimeter over fiber. Okay, obviously in 5G technology for backhauling, we are using millimeter waves. As I told you that we have fabricated a antenna which is resonating at 28 gigahertz. It can be used for the backhauling. Okay, this is the backhauling between the RAU and RRH. implementation of millimeter wave over fiber. So this is a basic simulation setup to implement the millimeter wave over fiber. So basically here we are using a data generator which generates the bits, and we are using non-run to zero. Here we have a form, and here we have a data in electrical form. Further, it is mixed with the sine wave. This is actually a millimeter wave. Okay, then we give this data to the laser, and this is called a direct modulation technique. Okay, another is external modulation technique. In this case, we are taking data, again data, then not to zero, which is mixed with the sine wave. Further, we will use MZM, which is a Mach Zehnder modulator, which is also called a amplitude modulator. Okay, further, this modulator amplitudes that electrical signal, which is mixed with the sine wave, uh, use over the optical carrier transmitted by this laser. So this is the transmitter setup for the direct modulation and external modulation technique. We got this pretty much good results. Okay, after I think we sent this data over 20 kilometer, because in the 5G technology, everything like every like structure is very nearby, since we are dealing with the microsecond, and you can see it has very good eye opening. Okay, for the direct modulation technique and for the external modulation technique. If we will see the spectrum of the proposed optical communication system, you can see here this is wavelength spectrum for the direct modulation. Okay, this is the before transmission and this is the after transmission. You can see the difference, but we are getting like that much power, which is above minus 10 dBm of power, which is pretty much good, because for optical communication, the power should be above minus 40 dBm for acceptable performance. I don't know why it's not coming. Comparison in tabular form. So I will skip this. Another one is passive optical networks. So in passive optical network, I told you that the only is not sufficient 5G technology. We have to go for some like advanced type of network, like passive optical networks. So basically, as the name suggests, passive optical network, the network which are using passive component and throughout the link at the transmitter side and the receiver side. Obviously, we can use passive component, but in between the transmitter and receiver, we can't use like active component. Okay, at the transmitter and receiver, we can use active component, but in between those, we need to use passive components only. Okay, which are working without any power, without any additional power. And those components don't use any type of batteries or any type of electricity. Okay, for the operation. So it also reduces the cost, since electricity and power is the major factor in the case of cost. If we are reducing the power, it means the cost of overall system will also reduce. Okay, so passive optical networks are having OLT, optical line terminal. Okay, which is basically a central office. This is actually a optical line terminal, and after that, at the other end, there will be a ONU, or basically we can also say that ONUs are users which can also receive and which can also transmit. We have to use passive components, splitter or coupler in between the transmitter and receivers, and we also have to use optical distribution network, okay, which contain the point to multi-point passive distribution network as the plant. Okay, so this is the architecture. having BBU and RRH. Okay, this is the front hauling having 12 kilometer of fiber. This is the internal architecture of the BBU, or we can say the OLT, having laser modulators with local oscillator. This is the architecture, another architecture of millimeter wave over fiber technology. Again, we are taking the other signal for the modulation, and we will have a EDFA, and we will have a filter just for the filtering some extra frequencies it has. Then it can further transmit it through the fiber. This is the example of one channel, but obviously we can't waste the bandwidth of optical fiber. We need to send multiple channels simultaneously using wavelength division multiplexing. At the receiver side, we have to use photodetector, then electrical filter, electrical amplifiers to just attain the acceptable performance. So if I talk about the evolution of PON technologies, okay, in 2004 to 2005, we were dealing with the EPON and GPON. EPON is dealing with the 1 Gbps speed. GPON is dealing with the 2.5 Gbps speed. In 2010, we were dealing with the NG-PON, which is like working on 10 Gbps speed. In 2015, we were talking about NG-PON 2, which is dealing with the 40 Gbps of speed. But this speed is commercial speed, which is commercially available. But my students are working on like terabit per second out speed, and we were our our um, our aim is to touch the petabit per second speed, but I don't know how it will be possible, but we will try to do that. Okay, so we will have a evolution of passive optical networks from EPON to GPON to NG-PON 2, and nowadays the researchers are working on NG-PON 3. Okay, so we may have NG-PON 3 by 2030 with the 6G generation, 6G network. Capacity trends for passive optical network. So passive optical network, it is working with the bidirectional properties. We have to use bidirectional optical fiber. Okay, so we will have downstream, we will have upstream. Okay, downstream has its own transmitters and receiver. Upstream has its own transmitter and receivers. So you can see here that the blue part is showing the downstream data rate, and the red bar is showing the upstream data rate. So I will more concentrate on these two technologies, which is the advanced version of PON, which is NG-PON 2 and NG-PON 3. NG-PON 2 is dealing with the TWDM PON. Okay, so for backhauling, there is a like variation of speed from 40 Gbps to 100 Gbps. In the case of upstream, there is a variation from 10 Gbps speed to 100 Gbps speed. Okay. In other words, the requirement of NG-PON 3 is the for downstream, we would need 100 Gbps speed to 250 Gbps speed, and for upstream, we would need 40 Gbps speed to 250 Gbps. So this table is representing the wavelength plan recommended by the ITU-T. ITU-T, I think everyone knows that it is an organization which defines the standard. Okay, so if you want to commercially launch any technology, then you need to follow this standard. Okay, but I am talking about terabit per second of speed, but they are not, the ITU-T is not recommending the terabit per second speed yet. Okay, so if you want to put your proposed idea into the market, then you have to follow ITU-T grid. So as I told you, there are evolution of NG-PON, sorry, passive optical networks from GPON to NG-PON 2, and we are nowadays we are talking about NG-PON 3. But the thing is, what ITU-T is talking about GPON, XGPON, and NG-PON2. Okay, the wavelength should be for downstream, it should be 4080 nanometer to 1500 nanometer for GPON. And for upstream, the frequency should be 1260 nanometer to 360 nanometer. Okay, if we talk about NG-PON2, it should be from 1524 nanometer to 1544 nanometer for upstream. For downstream, it should be 1596 nanometer to 602 nanometer. So if you are like proposing NG-PON2 technique, any simulation software like OptiSystem software or VPA software or OpSim software or MATLAB, then you need to select the frequency for uplink and downlink according to this standardized variation of wavelength. Okay. So the minimum number of wavelength we can use at the OLT side is 4 in the case of NG-PON2. Obviously, we can increase the number of wavelengths. So the bit rate is 10 Gbps for symmetric and 40 Gbps, that is the overall speed. Okay. Splitting ratio should be 164. Splitting ratio means at the receiver side, we are splitting the signal into the different users. Basically, we are broadcasting the signal to the 64 users, or we can say that 64 ONUs. Distance should be 40 kilometer, and multiplexing technique should be TWDM. So here TWDM is basically we are like hybridizing the two different domain. One is time domain and wavelength domain together. That is called a TWDM. So this is a basic concept of millimeter wave over fiber. That how we can generate the millimeter wave over fiber and how it works. So this work was published in 2018, and that was very interesting work, and this work is experimental work. So you can see here we are using laser, which is resonating at 193.18 terahertz, and after combining this light with the analog signal having 11 gigahertz of frequency, and if we are combining this at the output, we will have this type of structure. So you can see here, this is the actual frequency, but actual frequency has a less power, and the power is distributed to the side lobes, okay, which is F1 and F2. Then we use transmitter, okay, and amplifier to the, and we will do the modulation at this part. This is an MZM, maximum modulator or amplitude modulator. Amplify the signal. Okay. After this modulation, data not modulated on the actual frequency, it is the lobes. And the data modulated over the, okay, and they are same, okay. Then, as I told you, we are dealing with the picocells. So they have transmitted the signal over 11.8 kilometer of the fiber, and they have used photodiode, pen diode at that time, okay, and they got that much. This signal means they have suppressed the another side lobe, and they have detached the data from this signal. Okay, so this is how that the millimeter wave can be generated, and it can be traveled through the optical fiber. So this is the case for the single channel only. If you want to do work on this topic, then you can use multiple channels having advanced modulation techniques. I'll be showing the simple set of NG-PON2 we have implemented in OptiSystem software. And I have 18 version, which is the latest version in my research lab. So we have used 8 transmitters at the OLT side, and then after that we have used bidirectional fiber, and after that we have used a demux which is 1 to 8 demux. Then after we will have 1 into 4 splitter, okay, and we are using 32 number of ONUs in this setup, okay, and those ONUs also transmitting the data, and that data will be multiplexed and again transmit to the bidirectional fiber, which is received at another side having 8 receivers. Okay, this is the basic idea. This is the basic set of NG.2, and we are taking the frequencies which is recommended by the ITUT. All the parameters are according to the ITUT grid. This is the internal architecture of the transmitter. Okay, I already have discussed this, and I also have discussed this, which is a receiver part and that is a transmitter part. We got pretty much good results for 10 kilometer, for 15 kilometer, and for 20 kilometer. Obviously, for 10 kilometer, we got high quality factor as compared to 15 and 20 kilometer. Okay, 20 kilometer is the lowest one. Why it is lowest one? It is obvious that if we are increasing the fiber from 10 to 15 and 15 to 20 kilometer, more dispersion, more non-narratives will induced on the signal, and which degrade the performance. But still, it is acceptable, which is above 7, and the acceptable quality factor for optical communication is 6. If we want to convert into the dB, it will be 15 dB. So that these results represent the asymmetric TDM pawn. What is the meaning of asymmetric TDM pawn? Basically, asymmetric TDM pawn means like this transmitter is transmitting the data at 40 gigahertz in, oh sorry, not 40 gigahertz, Gbps, 40 Gbps, and this transmitter is transmitting at 80 Gbps. Okay, so both are not equal. This is a asymmetric transmission. If we will have a 40 Gbps of speed at this side, then 40 Gbps at this side, OLT side, 40 Gbps at the ONU side, means this is a symmetric architecture. So these are the results for the asymmetric architecture. So I'll be showing the result of symmetric architecture. Again, you can see that we got the result at 10 kilometer, 15 kilometer, 20 kilometer. So these results are submitted in Journal of Optical Engineering, and we got major revision in this case, but we are hoping that these results will be published in this journal. So you can see that again, the quality factor is above 7, which is pretty much good for the optical transmission. For quality factor of 6, the bit error rate is equal to 10 to the power minus 9, which is sufficient for the DWDM system. So after having these results, after proposing the basic architecture on to
सिक्योरिटी इंचार्ज टू सिक्योरिटी इंचार्ज लल हो गए अकाउंट ऑफिसर लल काट का कॉलम हेड भी काट ही देती हूं मैं 2 की जगह ब्लैंक कर देती हूं हाथ से लिख दूंगी सारे म्यूट ठीक है ना अब सही है सही है सर इंफॉर्मेशन गैदर ही तो करना है
okay. So this is a advanced architecture of NG.2, and we are working on this architecture, and we will get the results soon, and we are planning to communicate this architecture in IEEE quantum electronics or IEEE photonics modulators. So in this case, the previous setup was dealing with the non-N20, which is a traditional modulation technique. In this case, we will be using QAM. So basically, we will be using millimeter wave over fiber technology, plus we are using advanced technology, which is QM, plus we are using MG.2 system. So here we are using three type of different like advanced systems in one setup, and we got good results. Right now, I can't show these results in this presentation. I just can give you an idea that we can use like multiple transmitter, and the single transmitter having these components. Okay, then after that, it can be multiplexed by multiplexer. It can be transmitted through the bidirectional optical fiber. Again, at the receiver side, we can split into the many arms, and we can receive the data and transmit the data, and it can be multiplexed and it can be transmitted to the another end. And again, we will be using ITU-T grid recommendations. So that was the part of the communication system level. Optical signal processing is also very important for high-speed networks. Okay, so for example, we are getting 100 Gbps of lease line optical fiber into our home by using fiber to the home structure. But if we see the result at our laptop, if we'll see the speed of at the result, we are getting like only 100 Mbps, 200 or 300 Mbps of speed. Okay, so we are getting 100 Gbps from the service provider, but if we see the speed at our in our laptop, in our tablet or phone, it will be only in Mbps. How it is possible? This is because of the processing, the conversion from optical to electronic, and then we are using electronic signals. So the only solution to avoid this problem is optical signal processing, that we don't need to um, convert the signal, optical signal, into the electronic form, again into the optical form for the transmission. So the challenge is how the optical signal can be processed all optically with the high data rate without undergoing OEO conversion. OEO means optical to electronic and electronic to optical conversion. How all optical operation can be used in future secure optical networks and in other applications. Apart from the high capacity, high speed, the security is also a major issue. Okay, so it can be accommodated by using optical signal processing. So the approach which we can use to accommodate these challenges is by using the non-linear medium. So the major nonlinear medium is semiconductor optical amplifier. Nowadays, the researchers are using high nonlinear fiber as well, or photonics structure for getting nonlinear mediums. Okay, but in my work, in my research group, we are using semiconductor optical amplifier to propose AND gate, which is all optical AND gate, OR gate, NOT gate, XOR gate, NOR gate, then half adder, half spectre, digital comparator, and Johnson counters. I'll be discussing this part also. So by using semiconductor optical amplifier, by using the nonlinear properties of SOA, we had proposed all optical operations, OR gate, AND gate, XOR gate, and half adder, which were published in IET Optoelectronics, Optical Engineering, Journal of Optical Science of Korea, and Optical Engineering again. So you can see here that we have pulses. Basically, these are optical pulses representing data, which is 1 1 0 0 0 0 0 1 1 1 1. Okay, so this is data 1, and this is data 2, and this is the operation after AND gate. So you can see here 1 0 1 1 1 1 0 0 0. So you can see that the pulses are optical pulses are performing AND operation by using semiconductor optical amplifier. You can see here the performance of AND gate, XOR gate, half adder, this is carry, this is sum, This is data 1 and this is data 2. So this was, I think we have proposed this architectures in 2014. We got very good result and very in reputed journals. Security is also the major issue in education and healthcare in national defense sector. Okay, so since we are like already have proposed many algorithms for wireless communication to secure the data, but in the case of optical communication, it's still a open challenge that how all optically we can secure the data. Okay, because it is very easy to uh, cut the fiber and leak the signal. So, and that signal can be given to the multiple number of computers, and those computers can perform some algorithms to like crack the data. So, in the case of optical communication, we need some like all optical operations so that we can secure the optical data. So the challenges are how data can be made secure, even if eavesdropper can recover secret key. So as you know, for encryption purpose, we would need data which is further, um, we consider it do something logical operation by using secret key. At the receiver side, again, we need the secret key to recover the original data. And we have performed some operation by using um, orthogonal modulation formats. So what we did that we have um, uh, modulated that different data from the three different user into the single signal on the phase, on the amplitude, on the amplitude, on the polarization. Okay, so if someone wants to crack that data, he has to check that where the data belongs to. Okay, basically nowadays the popular modulation format is amplitude modulator, and the cracker has that much facilities only. Okay, they don't have facilities for to crack the data on polarization states or etc. So we have like put that data over the three different domains of the signal, and that was transferred through the fiber, and we got pretty much good results. That was published in Optical Fiber Technology Journal of Elsewhere in 2016 and 2015. During my postdoc, my supervisor told me that we are proposing many architectures, all optical architectures, uh, for the security purposes, but those architecture are not cost effective. So he told me that generate some idea or give some idea or propose some idea that how the data can be encrypted without using the secret key or by using less number of secret keys. So at that time it was like challenge for me that how can I do this. So that was the idea which was presented in the symposium in University of Rochester, New York, USA. So I have taken two different datas, data 1 and data 2, and I had make the different blocks. Okay, U1 one block, U2 two block, U2 one block. U2 means user 2, U1 means user 1. I have make the different blocks. It is representing a different blocks of 4 bits. First block, second block of first user, first block and second block of second user. So I wanted to mix those blocks into each other. Okay, so I have done this by using this working principle. So I have used control pulses, which controls the amplitude modulators. Okay, this is control pulse 1 and this is control pulse 2. This is data 2 and this is data 1. Basically, what I wanted to do, I want to make the blocks of data. Okay, and so that then after that I want to mix that blocks of user 1 and user 2 to each other to to encrypt the data all optically. So receiver part is basically a replica of the transmitter part. So this is the transmitter part. Just for the understanding, I have presenting this. This is data 1, okay, which is 110011. Okay. So I have used control pulse. This is control pulse, which is 000 and 111. Okay. For another pulse, which is control 2, that is a replica of this pulse. Okay. Basically, what I want to make the different blocks of this data, first block and second block. Okay. I have used amplitude modulator, which is operating with the control pulses. So you can see here amplitude modulator is having this control pulse. After having modulator, this part will be eliminated from the input signal. Okay, input signal is this. This is input data. So you can see here that that part is eliminated using control pulse. So you can see here that part is eliminated by using this control pulse. So I have a two blocks, which is 1 and 2. This is 1 and this is 2. Further, this is the data 11000011. By performing same operation, I got first block and I got second block. Okay, this operation has been done all optically. There is no any electronic to optical conversion. So after that, I have used the combiners, or we can say that couplers. Okay, by combining these two ports, which is 4th and 10th and 5th and 9th, I got this result. So you can see here, this data belongs to user 2 and this data belongs to user 1. This data belongs to user 1 and this data belongs to user 2. At the receiver side, we perform the same operation, we perform the same combination, and we got the original data. Okay, that was only the idea. So you can see here that these are the different blocks. Okay, this is for the mixed line rate optical communication system. I have taken the same idea which I have done earlier, but I have used the another scheme, which is mixed line rate. Mixed line rate means that one channel is working with the 10 Gbps and another channel is working with the 40 Gbps, and we are mixing these two channels into each other. Okay, and we are getting the garblet signal. So you can see here that at the same time duration, this user is transmitting its 4 bits only, but in this case the 12 bits are transmitted over the same duration. Okay, so this is the first block and this is the second block. I want to mix those datas. I want to swap those data blocks so that I can be secure my data. So you can see here, this first 4 bits are belongs to user 1 and these 12 bits are belongs to user 2. This belong to user 1 and this belongs to user 2. Okay, so to increase the speed, to enhance the capacity, we are using all optical operations here again. So you can see here, this is the original data of user 1, data of user 2, and this is the garblet data. This belongs to that user 1, that belongs to user 2, this belongs to user 1, and that belongs to user 2. This is user 2 and this is user 1. So this is the performance in terms of pie diagram. So you can see here that we are having same duration, okay, but we are getting multiple eye diagrams. Okay, So this is the red shows the eye diagram of user 1 and green shows the eye diagram of user 2, because on the same duration user 2 is transmitting multiple datas and user 1 is multiple signals, and user 1 is transmitting less number of bits. So that's why this is a mixed type of eye diagram, but we got pretty much good results because it is having like good eye opening. Okay, same in the case of same in the case of first sensor. So they, again, these results I have presented in the symposium organized by the University of Rochester, USA. The another technique is security enhancement using multi-code keying. So what was the idea? So this is a like original sequence. For example, 0, 1, 0, 0, 0, 0, 1, and 0. Okay. So this is the data which we want to transmit. But instead of that data, we can transmit the codes.
पदम सर की जो लैब है, लैब में आपको प्रोजेक्टर ऑडियो सिस्टम वगैरह चाहिए, वो सब भी करना है, हर लैब में चाहिए। सर सुनो, पदम सर की लैब है, सर ये लैब में होना ही चाहिए, होना ही चाहिए। फिर हम सर पदम सर के बने हुए मैं अपनी लैब में कैसे लिखूं बताओ?
Sir, your voice is not coming. Can you please unmute once? Simran sir? Simran sir, your voice is not coming. Can you unmute yourself?
Hello.
Yes. Dr. Chandan.
Yes. Yes, ma'am.
Sir, Simran sir, your voice is not coming.
Am I audible?
Yeah, now you're audible. And now your screen is also not showing, sir.
So you need to give me like a screen share option again. Yes.
I am doing again, sorry. So please check now. Sir, is it coming? Yes.
Am I visible?
Yeah, it is fine, sir, now. It's fine now. I request other participants to kindly mute themselves.
नहीं ना, एक भी नहीं है। मन्नू ने तो ऑलमोस्ट कर लिया है, उसने पेपर 2-3 जगह भेजे हुए हैं, पर बोल रही थी कि नाम मेरा हर जगह रिजेक्ट ही हो रहा है, पता नहीं क्यों रिजेक्ट हो रहा है। शिमाली सर ने क्या लिखवाया मुझे नहीं पता। मैंने बोला हाँ पेपर रिजेक्ट हो रहा है, मैंने बोला देख
Ma'am, you should talk to me. Ma'am, again you have to give me an option because somebody muted me.
So now please see.
Thanks, ma'am. Am I visible and audible?
Your screen is presented, sir, but you are not visible. I think
it's fine.
camera.
It's fine.
So no issues. You can switch off your camera.
Yes, it's fine. Okay. So this is the code for data 0 and that is the code for data 1. The idea is that instead of like sending the 0 signal, we can send a code. These are the optical pulses. All are the optical pulses in optical domain. Okay. So what we can do that we can transmit the high data rate signals, high data rate data instead of 0. Okay, in this time duration T1, this original data is transmitting only 1 bit, and I am transmitting the many bits instead of 0 in the form of codes. Same the case is in the code for 1. So you can see here, this is the codes for zeros, and this is the code for ones. So to implement this idea, we had used this setup. So in this case, we have used semiconductor optical amplifier, which is performed a NOT operation. Okay, what was the idea? So we have a original signal, which is original data, we can say that here, which is splitted into two arms. Okay, first arm, second arm. Then after that, we amplified this. Why we amplified this? So that we can saturate the semiconductor optical amplifier to perform the switch operation. Okay, so let's have an example that I have 0 bit splitted into two arms. At that part I have 0. Again I have 0 here. After NOT operation I have 1. Okay, again this is SOA and this is also SOA. So here SOA is used as NOT gate, and at this positions the SOAs are used as switch. So you can see here, whenever it will get one signal which is having enough amplitude to saturate this SOA. Okay, so in this case, this SOA work and this SOA will not work because it is saturated, because it has 1. Okay, in another case, if I have one data, okay, one pulse having one digital information, this side I have 1, and after NOT operation I will be having 0. Okay, so this SOA will not work and this SOA will work. If this SOA will work, this data, okay, which is having 25 Gbps of speed, will be transmitted to the output. Okay, basically if I have one data, then this code will be transmitted. If I have 0 data, then this code will be transmitted. So this all work has been done all optically without any conversion. This is called a multi-code keying. So you can see here that I have a original data and I have a encrypted data having different code streams instead of sending the signal. So apart from this encryption, we also have started working on quantum communication. Quantum communication. I have started working on this topic because this is very hot topic nowadays. Okay, at national and international level, or talking about quantum communication. The thing is that how we can transmit the quantum signal over the fiber. Okay, the major advantage of quantum signal is the entanglement. Okay, if there is any like changes, if somebody wants to leak the data in between the transmitter and receiver, the polarizing state will be changed. Then there will be a disturbance and entanglement at the output side. Then we came to know that yes, there is some problem. Somebody is hacking our data, so we can stop our data or we can encrypt our data. It's depend upon the application and depend upon the user. Okay, so even government of India is providing like lots of money on this topic, quantum computing and quantum communication. Another topic is quantum key distribution, QKD. We can say that to like secure the optical communication system without undergoing optical to electronic and electronic to optical conversion. So basically, quantum communication can be used for the high speed transmission. It can be used for the secure transmission. So if you will be using quantum communication, so you are getting two like different advantages at same time. So this is very hot topic. We are working on it. We have implemented this quantum key distribution. I can show that setup and results because we are actually on the way to communicate that work. And we also are trying to working on quantum switching. The problem in the quantum communication is the quantum signal is having the power of less than minus 70 dBm. So for WDM system, you should be having the signal should be having the power which is above minus 40 dBm. So means there are many things which you need to discuss, which you need to work on. So we are also working on this topic, quantum communication. In future, if I will have time and if I'll get opportunity to interact with you, I will discuss these topic after submitting our work in the reputed journals. If somebody wants to be a part of my research group, you can get different um, funding schemes from DST, Inspire Fellowship, Maulana Azad, Rajiv Gandhi National Fellowship, National Fellowship for the backward classes. If you want to do postdoc, you can access these three slides. And also, if you want to be a part of our university, you can apply for this fellowship, which is Inspire Faculty Fellowship. And if you will get this fellowship, you can be a part of our department and you can teach, you can do research, you will get research funds. And also, you will be getting around, I think, 1,25,000 rupees per month if you will get this fellowship scheme. I would like to thank all my PhD students, master students who really work hard, and I'm here to presenting them because maximum work which I have presented in this presentation is belongs to my candidates. These are my sponsors. I would like to thank all my sponsors who gave me projects and who gave me support during my research period. Thank you so much. Any questions, please? Discussion time, 15 minutes for discussion. If anybody has question or if somebody is getting problem in the case of optical communication system in your research.
So now discussion is open for the participants. They may ask some questions. I think, sir, there is a question in the chat.
Okay, the question is, out of ITUTs, D.652 and the IEEE 8.3, which is more standardized for optical communication systems? So I don't remember actually the names of standards, but I would suggest you that don't go out of the ITUT because like if you will be going, then you will get the comment from the review that why you are using the unstandardized frequency bands. Okay, so you can search over the ITUT website and you will get the standardized bands, and you have to go through that only if you are getting frequency from out of these bands, unlicensed band or unstandardized band, then you will get comments that why you are working on these bands only. Any other questions, please? Is it possible to apply compensation algorithm a high-speed optical network to regenerate the signal? Look, the thing is, it's very tough to like apply any algorithm in all optical domain. If you want to work on, like in my PhD thesis, I work on genetic algorithm, okay, to optimize the optical amplifier. So means it's at that time I was like came to the result that it could not possible to do perform the algorithms in all optical domain, you need to convert into the electrical signal, and you can work on that because you can save the bits into the computer and you can write the program and you can perform that operation. But since the optical signal is electromagnetic signals having like continuous amplitude, so you can't it is very tough to like work on amplitude having like uh, many amplitude values. Okay, interesting question. How we can get some good research projects in optical? I have like good experience in that case because in my research group 3 crores of projects are going on funded by government of India. So the thing is, if you really want a project, then it is actually a smart game. Okay, so you need to collaborate with the research groups who are having experimental facilities. Okay, uh, if you have a good collaboration, then you can put like researchers as co-PA. And another way is the another solution is the idea. As I told you that you should work on quantum communication if you really want a project in your lab. So if you want to work on your project, you should have good idea, you should have good presentation, you should work on methodologies. Okay, this is very important. The thing is, like I am also a reviewer of SCRB and DSD. I got projects, but they don't know. They have proposed very good idea. They have proposed the objectives, but they don't know that how to achieve the results. Like if I am an investor, I want to give you money, and you don't have idea, you don't have a methodology that how you can achieve those results which you have given the idea. Then how can I give you the money? This is very simple, like um, criteria. So the thing is, you should work on methodology that how the proposed objective can be achieved. Okay, you should mention um, uh, the softwares, the hardwares, uh, that I will use this hardware like in this way, I will use this hardware or software in this way to achieve this. Okay, so you should elaborate the methodology as much as you can. If you talk about the funding agency, I would suggest you should go for SERB because the other funding schemes are giving the money, but they are very late. But in the case of SCRB, I am very satisfied because the response is very quick, and you will get the first approval within I think 5 to 6 months, and after that you will get your money in just 1 month. So I would suggest you to go for SCRB. SCRB is having like many different schemes like co-research grant, extramural research funding for women, especially for the women. There is PAR fellowship, PAR research scheme. These are two the different research schemes. So you should go for these SCRP. Any other question?
Thank you, sir. Thank
We
you so
can
much,
design.
sir.
Is there any research going on or it's already done? So yes, already even I have implemented all the gates. Okay, using SOA. So it is not a new topic that you, but yes, the thing is you can work on optical processors to propose a optical logical operation like combination circuits, sequential circuits by using semiconductor optical amplifier. You can do this. Any other question, please? Over to you, ma'am.
Okay. Still, if there are any queries, you can directly contact our expert or through me. Sir, it was really nice interacting and looking at the research, what is going on at Punjabi University, Patiala. So we'll be having more collaborations in the future to come. Really thanks for such a nice talk. Now I would request Ashi to say a few words. Over to you, Ashi.
I would like to thank Dr. Simranjit Singh, sir, for his insightful presentation on high-speed optical network for 5G and beyond, and for providing deep insight into his research at passive optical networks and optical signal processing. We thank you, sir, for this informative session, and I'm sure all the participants have gained a lot. Thank you, sir.
Thank you, sir, for being a part.
My pleasure, ma'am. Okay, bye-bye to everyone.
Okay, sir. Thank you once again. So now, regarding our next presentation, it is scheduled at 2 o'clock. So just join 5 minutes before 2. Thank you all for joining the session.
Hello.
Yes, sir.
Good morning, ma'am. Ma'am,
Good morning, sir.
actually, I have a query that you are going to conduct a MCQ-based test in the after the validity session. So, what would be the syllabus for that MCQ test?
Sir, it will comprise of optical and wireless technologies. The basic questions would be there, sir. And the test will be of 30, minutes, and the question will be 40.
Okay, okay. Ma'am, is there any separate feedback link for ATAL FDP that we have to fill on ATAL portal? No?
Sir, can you repeat?
Ma'am, we have all the participants have to give the feedback on ATAL FDP portal also, no?
Yes, sir. I'll convey you that in the closing session, sir.
Okay, madam. Okay. Actually,
Okay,
that is the mandatory requirement, na?
yes, sir.
Okay,
Thank you,
madam.
sir.
Okay. Thank you, ma'am.